Thank you so much for being here. I'm so excited to have Dr. Robert Roundtree back to give us sort of the part two of the talk for the immune system. He's one of my all-time favorite teachers of the immune system, and we are going to dig deep today and get a little more specific. I want you to think about today as your group functional medicine consult, right? We're going to kind of take you through what a functional medicine would think about when they have a patient in front of them. Dr. Rountree is a family practice physician. He's also well-versed in holistic medicine. He's an expert in nutrition, herbal medicine, mind-body therapies. He lectures on the toxins problem and its impact on human health. He's the author of multiple books. And I would say, Dr. Rountree, your superpower is making the complex simple and easy to understand. With humor, actually.
Okay.
Yeah. And so, in our part one talk, we talked about how an autoimmune disease like MS might develop. We talked about immune tolerance. We talked about the hygiene hypothesis and why dirt is good for you. We also talked about how important the environment is and how it can set you up for autoimmunity. And we also talked about ways to slow down an autoimmune process, including lifestyle and supplements. So today we're going to build on that. And I want to convince you beyond any doubt that your care isn't complete until you start incorporating principles of functional medicine via your routines and your behaviors. So as we're talking, I want you to be actively thinking to yourself, has my doctor already talked to me about this? Or is this something that's already on my radar? So today, hopefully, we'll spark some ideas for you to pursue and start layering on different tools to actually get your immune system to behave a little better, to stop being so rogue and creating inflammation and autoimmunity. We are also joined by Katie Sloan, who is an amazing MS advocate. She is going to monitor the chat. And so please put your questions in. There are no bad questions. We'll either get to them through it during the conversation or after. Okay, so with that, Dr. Rountree, thank you so much for being here. It's really an honor to have you.
Good to be back.
So I wanted to start with having you make the case for why a functional medicine approach matters so much when we are trying to reel in that immune system. So can you kind of tell us why it's important and what is the best approach to improving overall immune health?
Okay, I'll try to make this understandable, but I guess I just have to start by thinking, what are we as human beings, right? We're not our immune system. We're not our nervous system. We're not our gut. We're a collection of all those things, right? We're our livers and our kidneys and our brains and our blood, the circulating white blood cells, the red blood cell. We're a system. And that system it's all functioning like in some amazingly coordinated way. How is it coordinated? We don't know. We don't really understand, but somehow it works, right? And when I say it works, if you get a cut, then your immune cells all come together as a team, as an orchestra, really, and do what needs to be done to expel any potentially bad bacteria, clean up debris, and heal the wound, right? How does it do that? Yeah, and I don't know. I'm looking at you and you're like, I don't know. I mean, so what I'm saying is kind of semi-miraculous things happen in our body all the time. Now, if a person has diabetes, then they don't take it for granted that that paper cut is going to heal, right? Something goes wrong with the immune system. Now, what was it that went wrong? Why didn't that wound heal right away? Well, obviously it has something to do with sugar. The glucose is too high, and so insulin's out of whack. Is it the insulin that's messing up the immune system? Is it the excessive glucose that's going rancid? Yeah, sugar goes rancid. People think fats go rancid, but sugars go rancid as well. And when they do, they damage immune cells. And then the immune cells start acting in really untoward, inefficient ways. So as long as the system is working, we think everything's great and we take it for granted, and so what? And then something goes wrong, like a person with diabetes that gets what's a small wound on their foot, and then all of a sudden that wound gets out of control, and then they've got an ulcer, and then they have to have an amputation. I mean, that's an extreme example, but it happens to people all the time. So when we think in terms of the system, then we also have to ask what keeps all those different parts running smoothly, right? How do they function in a coordinated way? And functional medicine specifically asks about all those different parts. How's the gut doing? What's going on with the circulation? How is the liver and the gut detoxifying?
And that's what I really appreciate about functional medicine, that it's not that it's better than a Western medicine pharmaceutical approach. It's a different approach that takes into consideration the whole organisms.
Yep.
And, most of us that practice functional medicine don't just like specialize in one function, like, oh, I only do detox. Like you really can't, because then you're missing the rest of the organism, right, that's sitting in front of you. And it's really beautiful to learn all of the biochemistry behind how all these systems function separately and together. And it's just been like one of my favorite things to learn in all of my medical training is to have this like holistic approach to understanding how the human body functions. And even though you learn all this stuff, you do kind of sit back and go, I just don't even know how it all happens and gets coordinated. Even though, like, yes, on a intellectual level, I can spit it out, but it's just so magnificent.
It's magnificent. I
Yeah.
will say in medical school, you learn the mechanisms of disease just enough so you can have some idea of how a drug might work. But then once you've got to the point of understanding how the drug works, that's kind of the end of the learning. I mean, I hate to say that, but
A perfect example of that is detox. Med school, you learn about the liver, but you never really learn about these different detoxification pathways and how they can impact health and toxin metabolism, detoxification. So I think there were big chunks missing out of my medical school education that I think functional medicine was able to fill in and give me words to describe.
one concept that was never brought up in my medical school was a concept that's being referred to now is the total toxic load, right? In conventional toxicology, they look for a connection between one chemical or one metal and a disease. So, we're talking about multiple sclerosis today, right? So you might look for papers that say, is there a particular chemical that's associated with multiple sclerosis? And actually there's some studies on solvents in particular showing that certain solvents can predispose you. But in conventional toxicology, the focus is always on what does this one chemical do? And so let's take laboratory animals and let's bombard them with this chemical. Let's, put benzene in their drinking water and see if they get cancer or MS or something like that. But they never ask the question, well, what happens if you take the benzene and you mix it with a little mercury? And you mix that with a little cadmium, and you mix that with PFAS, which are everywhere in our environment, and you mix that with microplastics. And what if that laboratory animal has got a vitamin D deficiency? Oh, well, what if that laboratory animal isn't eating enough? That rat's not eating enough salmon.
Right. I mean, you've just described what happens in an ordinary human being, right? We're not exposed to one toxin. We are exposed to thousands of toxins. Nobody tests clean and they interact, right?
Right. And so what happens if you've got an individual that for some reason, let's just say genetics was the start of it, that their liver just doesn't get rid of toxins very well. So we're not just talking about one toxin. We're talking about whole families of toxins. A typical person has detectable levels of at least 1,000 different chemicals in their bloodstream and their body fat, et cetera. So what if a person genetically is unable to get rid of these things? And we get rid of them by attaching certain chemicals to the toxin. So if it's a fat soluble toxin and we don't do anything to it, it'll end up in our fat, right? It'll end up in our brain, our kidneys, our body fat. If it's water soluble, eventually you'll pee it out, but it may cause harm along the way anyhow. So what if you have a person, again, that can't process the toxins very well? And then they also have, as I said, a vitamin D deficiency, right? That's not looked at in conventional toxicology, but it's something we talk about in functional medicine all the time. So I might measure a person's capability of eliminating toxins. I might look at their diet to see if they're eating foods that will help them eliminate toxins, like broccoli, which will, you know that I like broccoli. So
Oh yeah.
come back and talk
Broccoli
about, oh yeah,
with turmeric.
broccoli and turmeric. Yeah. So what if the person's not eating those foods? What if they're nutritionally inadequate? And there are many published research studies in medical journals that show that if people are undernourished, right, if they're not getting the right kind of nutrients, if they eat ultra processed foods, then that interferes with their ability to lower their total toxic load. So total toxic load simply refers to the combination of all the different things that maybe their own body is making, right? The gut bacteria, they make toxins. So what about what we're exposed to in the workplace or in our environment? You know, what if you have a gas stove? Which
Yeah.
I have a gas stove in my cabin up in the mountains. I love it, right? It cooks great, and it's terrific when the power goes out.
Yep.
But more and more with new studies coming out about gas stoves, I'm kind of scratching my head and looking at it going, really? You know, what am I going to do here?
Yeah, I know. That's getting phased out here in California real quick.
They're going fast, but you know, at the same time, if you live in a place, you know, like my place up in the mountains, power can go out for 3 or 4 days. If you don't have a gas stove, you ain't eating.
Yep. Absolutely. So what you're getting at is we're all exposed, even at minuscule amounts. These compounds can interact with each other and create a much bigger, badder problem than just one toxin by itself. We don't study that
We don't
in
study it
conventional
in medical
toxin.
school, but it is being studied. It's not like it's not happening. In one place, I'll point out for people who want to track this, Stanford.
Oh,
Can
I
you,
know
yeah.
Stanford.
Yes, you know about Stanford. The research that's going on there right now on what's called the exposome is groundbreaking. And what they're having people do is walk around with these little devices that basically sample the air the person's breathing, and then they take regular stool samples and blood samples, uh, and then put all that together and say, okay, over the course of a year, what's this individual exposed to? And they found even people that live together have slightly different exposures. So this research on what's called the exposome, which is everything we're exposed to, this is groundbreaking. This is going to change the nature of science, because if Stanford says this is cool to look at, you know, then other medical schools are not going to be able to ignore it.
It's important. I mean, it's been hard to study the impact of toxins, but we're getting there. And there's enough information for us to act, because we know that toxins can interrupt the immune system, the gut microbiome can be damaging to the gut. And I love how you went straight to like broccoli
Yeah.
and not like some expensive supplement. So real quick, what can we do to leverage detox to help improve immune health?
Okay. So there's this pathway, and this is technical, so I'm going to get it. It's called the NRF2 pathway, the NRF2. And I can't tell you exactly what NRF2 stands for. I've memorized it more than one time, right? And it's interesting because we knew for years that people that ate a lot of broccoli and other vegetables in that family, the brassica family, we knew that people that ate them seemed to have less cancer, right? So, you know, the original concept was people who eat more fruits and vegetables have less cancer. But then they start narrowing it down, saying, well, it's not all fruits and it's not all vegetables. And hey, brassica vegetables in particular seem to have a particularly potent effect. And then researchers at Johns Hopkins said, well, what exactly are they doing? And it turns out there's a family of chemicals that are in brassica vegetables, and these chemicals are called glucosinolates. And why are they there? Because the plant makes them as pesticides. So if you take a chunk out of broccoli, it immediately gives you this kind of bitter flavor. Same thing with raw cabbage. You get a bitter flavor. That's because when you bite into the vegetable, it liberates an enzyme called myrosinase, and that enzyme converts this chemical, the glucosinolate, into something like sulforaphane, what's called isothiocyanate. Again, I'm going to leave the technical stuff behind, but you'll see why I'm emphasizing this in a minute. So at Johns Hopkins, they discovered all these pathways. Wow, when you eat broccoli, you get this chemical called sulforaphane, and it activates a pathway called NRF2. And NRF2 turns on DNA to make all kinds of protective proteins. And those protective proteins include enzymes that lower the toxic load. How do they know this? Because they did a study in, I think it was the Yangtze River in China, which is a pretty polluted area. So the researchers at Hopkins found out the most potent source of these chemicals is broccoli sprouts, right? So you want the most bang for your buck, broccoli sprouts. They took the broccoli sprouts and they made a drink out of them. And they had people in the Yangtze River Valley drink the broccoli sprout juice. And it's funny, I saw a picture from a presentation by Dr. Jed Fahey, who did this research. And he said, and it's a great tasting drink. And this person is just making the worst face possible when they're, like, so, and it tastes great. Well, actually, I love broccoli sprouts. I eat them several times a week. They don't taste bad at all, but when you put them in a blender and you make a drink, it's got that bitter flavor to it, right? So they had people drink this stuff, and then they measured toxins in their urine. Within 24 hours, the toxins in their urine that were being excreted went up dramatically. And as long as they continued to drink the drink, which was good for them, like how were they compliant with this for, like 6 weeks or so, and they kept peeing out the toxins. So this is pretty profound. Well, what does it have to do with MS? One of the more popular drugs for MS right now is called Tecfidera. And it's part of a family of drugs called fumarates, right? What's their mechanism of action? They activate NRF2.
There you go.
There you go. So I go, well, wait a minute. If your goal is to activate NRF2, how about if you ate broccoli sprouts every day?
Yep.
Or healthy coleslaw?
So, it goes to show that food is powerful. It works with your body. It can really promote these detoxification pathways, turn on antioxidant genes, turn down inflammation. You just got to start getting those foods in, and we always talk about a whole foods, plant-based diet. So
your 9 servings.
What's that? Say that again.
Your 9 servings of fruits and vegetables. Our friend Terry Walls, that basically piles it high on the plate.
Yeah, absolutely. She gets in massive amounts. So, detox isn't a buzzword. It's not a fad. It's actually built into your body. And without detox in place, you actually wouldn't survive for very long. And so here are just a couple of things you can do, right? Like eating plant-based foods, broccoli sprouts,
curcumin.
Yep, turmeric, all of these, high potency foods that'll help promote these detox pathways to work faster, right?
Right.
So can we talk a little bit about mitochondria? Because I kind of have an obsession with them. They're so fascinating to read about and learn about, and these tiny little parts of our cells that produce energy for us in the form of ATP molecules. Can you talk to us about the role of mitochondria in immune health?
Sure. So mitochondria are basically enslaved bacteria. In fact, the theory is that they were a kind of bacteria called rickettsia. And Lynn Margulis, who used to be Lynn Sagan, you remember Carl Sagan? She was married to Carl Sagan, right?
Oh.
Brilliant. So Lynn Margulis Sagan, brilliant scientist. She married Carl Sagan, and he just wanted her to cook. And she said, I'm a scientist. That's not what I do. But she kept saying, you know, the DNA in mitochondria. So mitochondria has its own DNA, right? Its own nucleic material. And it's different than the DNA in the nucleus. And that DNA resembles very closely the DNA in certain bacteria. So the way the theory goes is that as the Earth was evolving about 2 billion years ago, roughly, there were new bacteria called cyanobacteria that had the ability to utilize sunlight to make energy, and then they produced oxygen. Now, other bacteria could take that oxygen and use that with glucose to make energy. And if they could do that, they're much more efficient. If you only use glucose to make energy, you have to have a lot of glucose. But if you use the glucose and the oxygen to make energy, you can make a heck of a lot more of the energy molecule ATP. And so I'm telling you this because that's what allowed for multicellular life. We could never have had multicellular life without mitochondria, right? So how many mitochondria you have in a cell? Oh, you know, a couple of hundred to the tens of thousands. And which cells have the most mitochondria? Heart, brain, right? Cells that are utilizing a lot of energy, that ATP currency. Now, the reason this is all getting really fascinating is because we used to think all the mitochondria did was make ATP. Now it turns out that mitochondria basically control the whole life and death of the cell. So every cell in your body every living cell has got mitochondria in it. And if those mitochondria aren't healthy, the cells don't function right. And part of what determines how healthy those mitochondria are going to be is the balance between these chemicals called free radicals, right? Most people think of that as like rancid fat. So iron will rust. That's a result of free radicals. So free radicals versus antioxidants. That balance has a huge impact on how well mitochondria work. And the reason that I'm going into this in so much detail is because we know that certain immune cells that are responsible for basically programming whether the rest of the immune system is happy. These are cells called dendritic cells or macrophages. Whether you have the right balance of free radicals and antioxidants in those cells determines how happy they're going to be. And if they're happy, so, you know, I'm using an anthropomorphic term, but yeah, you want your dendritic cells and your macrophages to be happy because they're the cells that are telling the rest of the immune system, are we under attack or not? Stranger danger. So here's the problem. We're surrounded with strangers, right? Our mouth, our nose, our gut is full of strangers, right? Bacteria that are not of us. They're foreigners. And so the immune system has to decide, you know, literally decide, well, are those strangers going to attack us or not? Should we be worried about them? Now, if dendritic cells, macrophages, if they're not functioning properly, they're going to start sending the wrong messages. They're going to start believing that the body's under attack, and they're going to send out chemical signals with little messaging molecules called cytokines, right? And suddenly cytokines used to be really esoteric, right? Now all the drugs being used for certain autoimmune diseases are anti-cytokine drugs.
Right.
And we know that at least with a subset of people that have MS, there's a cytokine called interleukin 17, IL-17. Mm-hmm. And it's not everybody with MS, but a lot of people with MS, I think, especially people who have very progressive disease, their interleukin 17, that cytokine goes way up. Well, why would the immune cells be overproducing that signaling molecule? Well, one of the theories is because they are misinterpreting the presence of what should be healthy bacteria, right? This ties into the hygiene hypothesis.
Yep.
So if these sentinel cells, they're the ones that are kind of sitting on the mountaintop going, okay, is it all good, all quiet, Western Front, everything's good? Or are they saying, I don't know, things look a little suspicious. And there's this weird virus, Epstein-Barr virus. And I'm kind of seeing it floating by every now and then, and I'm starting to think maybe we're under attack by Epstein-Barr virus. And maybe we should alert the rest of the immune cells that we're under attack by this virus. And those immune cells should start making a lot of antibodies.
So yeah, there's all this talk about viruses, including EBV, being closely correlated with the onset and progression of MS.
Yes.
What can we do if we have damaged mitochondria? I wanted to kind of get into this topic of mitohormesis and how we can sort of feed our mitochondria. Like, what would be some actionable things people can do to get the mitochondria to bounce back?
Well, the first thing you want to do is eat a clean diet, right? Sort of obvious. Now, it doesn't have to be 100% organic, but the closer you can get to that, the better. You don't want to be exposed to a lot of the chemicals that are out there, like Roundup, glyphosate. It's all over the place, or these PFAS, the Teflon-derived substances. They're all over the place. Now we're finding out they're in that wrap. If you buy meat in the grocery store and there's that shiny surface on the inside of the paper they put on the meat, that it's actually leaching out these chemicals. So you want to start by eating fresh, right? And I think that's a good rule for everybody. And even people say, well, I can't afford organic, it's too expensive. Well, at the very least, you want to get away from processed foods, things in packaging.
Yep.
Right? So do I avoid every single thing in a box or package? Absolutely not. No,
Right.
I don't only eat things from my garden in the backyard, but I try to eat, my wife is becoming a master gardener. She grows arugula. She just harvested our first arugula harvest. One of the best things that you can eat, arugula.
Oh, it's so good for
Also,
you.
in England, they call it rocket.
I like that.
I love that. So again, eat fresh. Try to eat salads and greens and the broccoli sprouts that I mentioned, berries, every single day. So eat fresh, minimize packaging, and minimize, things that are in plastic wrap, boxes, things like that. So that's the first thing. And that itself will lower your total toxic load. And then the second thing for your mitochondria is to eat color. And my friend, Dr. Deanna Minnick, I think she's written a whole book about this, the rainbow effect, right?
I mean, she's all about
all
the
the colors. She's all about the rainbow. And she's right. But, if that's too complicated to think about, just eat your berries. Eat your blueberries every day.
Good. So fresh foods, color. What about some other?
Okay. Exercise, obviously. What kind of exercise? I always get asked that. What's the best thing for mitohormesis? How do you make more mitochondria? The best exercise is the exercise that you can do.
I love that. I mean, if we said it was like this exercise, like not everybody's going to go do that, right? And you don't even have to do, excessive exercise to get benefits, right? Like people think that they have to be running for a long period of time. I mean, even modest amounts of exercise can sort of recalibrate your mitochondria so that they work better, you make more of them, right?
It's moving and breathing is how I think about it. So anything that gets you breathing a little bit harder, walking at a brisk pace. I'm a swimmer, so that's really what gets me excited. I swim a couple of miles a week, and I love it. I love being in the water, and it's good for the joints. You don't have to worry about damaging your cartilage, etc. So for people that that feel comfortable in the water. My patients, I really encourage them to get in the water. I had a patient with MS years ago that really loved to go jump in the cold creek here in Boulder. And, he didn't do it in the winter, but as soon as it became tolerable, he would go jump in the creek every day in this, almost ice cold water, and would regularly report how much better his symptoms were.
Absolutely. I think a lot of people are getting interested in these like cold showers or like dipping into cold water. And I can tell you, I always tell the story of how I did that at a river, glacial river in near Banff. And for
Oh,
hours, I only even submerged that. It was shallow. So it was only like the front half of my body. 45 seconds is all I did. But for hours after that, my mind was clear.
yeah.
My mood was calm. Like it was unlike anything I've experienced. Like it just was not me, but it was like a me that I really liked. So I try, and just getting out of your comfort zone a little bit. Don't be at the same temperature all the time. Give your body these little stresses to help build more mitochondria.
So that which does not kill you will make you stronger, right? So I'm
Usually,
not telling people to do do things that are ridiculous. And, my context is living in Boulder, Colorado. There are a lot of athletes around here that do extreme things, that run up the hill behind me. I'm not saying you need to do that, but I'm saying if you push yourself a little bit, and now people with MS have to be really careful, because if you overdo it, then there's that post-exertional malaise kind of thing. So I'm very cognizant of not saying, hey, go out and run till you drop. But there is a certain tolerance level, and most people know what it is for them, that if you push yourself to that tolerance level, that actually stimulates you to make more mitochondria. Why is that beneficial? Because more mitochondria make for a more efficient metabolism, lowers blood sugar, improves muscle function, improves brain function, improves neuron function, improves immune cell function. So you need to figure out exactly how much you can push.
yep. I like to tell people like, can you do 5 to 10% more than what you
Yeah.
normally do? Just like do it slow, don't be a hero. But I love that you just said exercise does all those things. And in a Western medicine approach, we have to attack each of those things separately, right? If your blood
Yep.
pressure is high, we give you a medication for that. If your blood sugar is high, we give you a medication for that. But exercise will simultaneously help you put all of those things back towards a more normal place. And that's really the beauty of a functional medicine approach.
Right. And so again, it's finding out what is exactly the right amount of exercise. So
Yep.
what we know is being sedentary, is the new smoking.
Yeah,
It's
for
the new.
sure. And you don't have to be an unhealthy person to fall into that trap. Like I work from home now. I
Yep.
sit quite a bit and I have to like set alarms to get myself out of my chair, stand up while I'm working. So for anybody listening, can you just sit less, right? Like you said, sitting is the new smoking. Yeah,
My Apple Watch actually tells me you need to get up.
there you go.
So I can either get mad at the watch or, I don't want to kill the messenger, but it makes a good point. Like just get up, move around, do something different just for a minute. That makes a difference. And again, I know I'm coming back to swimming, but that's one reason I recommend swimming a lot, because it's kind of hard to overdo it in swimming because there's so many different levels. Some people just get in the water with a little float band around and then just kind of barely walk up and down. It's supported exercise. Great stuff.
Yeah, there's so many ways to move your body, even if you have physical limitations. Like there's adaptive exercises, talk to your physical therapist. There's always a way. I have a friend who's a quadriplegic, and she has somebody just passively move her body, and she gets into a pool and says like that's the best, that's her favorite part of her week when she gets to do that. So just a little creativity and just thinking outside the box to find exercise that works for you.
One thing that Terry Walls did, which we've talked about, is she got little muscle stimulator, little electrical stimulators to actually get her muscles to contract.
Yeah.
And so she went from being in a wheelchair to dancing. And I've danced with Terry, so I know, I know what she's talking about.
Yeah. So it's not cheating, right? Some people will make that comment of like, I've heard it, no, she did more than just diet. Yes, she did lots of things. And
Everything. That's the system.
yes, you want to treat all the systems. So don't use just one tool. Layer on your tools. You do your Western medicine medications, and then you layer in all the things that we're talking about today. So, most of the patients we get in functional medicine aren't simple. I'm always like, oh, I want a patient to just come in and tell me my finger hurts, right?
Yeah.
Hasn't happened. My
Yeah.
average patient has like 30 medical problems. They're on 30 different medications. They might even be on 30 different supplements. And where you're like, oh, where do I start? So I want you to take us to the gut, which is where I kind of cheat. And I'm like, let's just work on gut health. So can we talk about the role of the GI tract, the gut, on our immune system? And maybe some simple things we can do to just kind of get started in bringing that system back into balance.
Okay. So maybe you're going to say this is TMI, but I just had my screening colonoscopy about 2 weeks ago, right? But one thing I was thinking about after the colonoscopy is those guys are not looking on a microscopic level, right? All they're doing is saying, well, we didn't see any ulcers or bleeding or cancer polyps. We didn't see anything like that. So you're fine.
And you're like,
But
I'm not fine, right? I mean, not you, but I'm saying a lot
yeah, but what about the
not.
people say, well, I have gas, I have bloating, I have indigestion, I have abdominal pain, I have abnormal bowel movements, frequent or not frequent enough, so the people have all kinds of motility problems, and you don't see that on a colonoscopy. So yeah, I mean, I love the fact that we have gastroenterologists that can look to see that there's not terrible things happening on a macroscopic level that you can see. But the kind of problems we're talking about that are happening in our society are microscopic, right? A typical person has got something like 40 trillion bacteria in their gut. That's a lot of bacteria, right? A typical person's got about 3.5 pounds of some kind of fecal material in their gut. What's in there, right? It's a very complicated system. And there's now paper after paper after paper connecting abnormal mixtures of bacteria in the gut with all kinds of diseases, autoimmune disease, heart disease, mood disorders, etc.
Right.
But we know that what the gastroenterologist can't see with the scope is really critical stuff, right? And we're getting there with our ability to do gut microbiome testing, where a person sends in a fecal sample and we look to see what's growing in there. I actually got through undergraduate school working in a micro lab, so I spent my days like putting things on cultures.
Oh,
We
you were that person. I always wonder who's the person that like scoops it out and
That's like swabbing plates, and then you put little antibiotic disc on there to see what grows. But we could only study what we could grow,
yeah.
right? That's all we knew. And then came the advent of DNA testing. With DNA testing, suddenly we went, oh, there's more in there besides E. coli and salmonella and all the standard bacteria that you've heard about. There are tens of thousands of bacteria, thousands of species, and a lot of them we don't even know what they do. So we're right at a new frontier of being able to understand that.
And even, fast forwarding maybe a couple more decades, we will understand more about the metabolome, right? Like the overall metabolic activity of these microbes living within us. That might even be much more helpful than just counting who's there and who's not. But the technology is not there yet. We're getting there. And we right now we're not great at measuring function, right? We just kind of
Right.
look at structures, we do an MRI, that doesn't tell you about how things actually function in a normal,
There are a couple of labs, including one out of Stanford that Dr. Snyder put together. And I've actually done that test. It's a very interesting test. But you do a blood sample, and then it measures all these different metabolites, breakdown products of the things that we're eating or that the bacteria are producing. And we're starting to be able to read the tea leaves and understand what all that means. We're still not at that place, right? But you can imagine, like in the early days, not even knowing that blood cholesterol meant something.
Right.
And then going from, say, we can look at total cholesterol. Now we can look at LDL cholesterol and HDL cholesterol. Oh, now we can look at LDL particle size. Now we can look at subtypes of LDL. We can look at lipoprotein little a. So we can look at all these different fragments. And the same thing's happening with the thousands of chemicals that are in our bloodstream at any particular time. We know that those chemicals in circulation alter and impact our immune system. So that's when I say it's the system that's important. So I had a patient recently with MS. She's on Ocrevus, right? It's not a bad drug as drugs go, but it does one thing. It knocks out B lymphocytes. B lymphocytes make antibodies, and it was helping her symptoms a lot. But it's not the whole picture, is my point.
Right.
Why did those B lymphocytes go crazy in the first place? That's the question. Was it the dendritic cells and the macrophages that programmed the T cells and the B cells to go awry? Is that where the problem is?
So this
Let's
is where
look at the system.
yeah, the concept of like going upstream and
Yes.
thinking about what came first and can we change those factors that are driving this autoimmune process forward? I think that's a really important question. And there's a question about fecal transplants. What do we think about that, Dr. Roundtree?
I think they have a lot of potential. I don't think it's going to be the future, because when you transplant the entire, what can we call it? The fecal microbiome, right? The human fecal you potentially can transfer things you don't want. Right?
Right.
So there's very good data out there that people that get a certain kind of colitis called C. difficile colitis, that fecal transplants are by far and away the best treatment for that. 99% effective. There's nothing in medicine that's 99% effective.
Totally.
Right. So that's a situation where I don't have any doubt that fecal transplants are the way to go. I
But that's
think the
not,
problem is some people have gotten fecal transplants and have gotten really sick from it. Some people have gotten transplants that were thin. They were thin and they got the transplants and they became obese. So we can't yet predict like
yeah.
what that's going to do. And yeah, we can screen them. But again, if somebody has MS or ulcerative colitis, another situation where I get asked about that all the time, is this the way to go? Well, I don't think it's quite ready for prime time, but it's interesting. Maybe in a very controlled environment, if you could get in a study, where they're using what's called super donors. I love saying that term. Could you imagine what kind of screening you have to go through to get called a super donor? Right? That means that they're paying you to go to the bathroom in their lab.
I'm just having these images in my head and I'm like, I wonder what they pay and what do you have to do to be one? But maybe we can, rather than like going to the last thing maybe you would go to for a patient who's got severe gut issues, which would be maybe a fecal transplant. What are some just like easy things we could do to start rebuilding the gut function, the microbiome?
Yeah, over and over again. I mean, you might think it's probiotics, and I think probiotics are fine. I take them, I recommend them, but the data overwhelmingly shows that prebiotics, which are substances in food that feed the healthy bacteria, that prebiotics make the biggest difference for the longest period of time. And so what are those prebiotics? Well, there's a range of them, but they're mostly indigestible fibers, right? And so this is a little bit of a paradox for some people that say, well, I've got irritable bowel syndrome and you're telling me to eat fiber, it's going to give me gas. And they might think, well, this is a bad thing. And yet the studies have shown that when you eat the Mediterranean diet, which has got a lot of prebiotic fibers in it, yeah, people can get a little bit more gas and a little bit more bloating when they do that. But when you measure their gut microbiome, it's all changed for the better.
So just put up with a little bit of gas and bloating. And these are the prebiotics are foods like onion, garlic, green
Onions,
vegetables, banana, kiwi,
yeah.
mushrooms. I mean, you can Google a
Powders,
list.
you can buy if you really don't like salads and if that's too big a transition, you can buy prebiotic powders, right?
Yeah.
There's a number of them out there that have green banana flour, unmodified potato starch of all things. So when you take potatoes, which we used to think were bad, 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 it's all carbs, right? Never eat them. And even white rice, we used to say white rice is all bad. It turns out when you take rice and potatoes, you cook them and then you cool them. When they cool them, it forms what's called resistant starch. And resistant starch turns out to be really good fuel for healthy bacteria in the gut.
That's really cool. I didn't know that you had to cool the rice.
You cool it, so you put it in the refrigerator.
Yep.
So that if you when you go get sushi, that's got the sticky rice in it, that's the kind of rice that I'm talking about.
Yep.
That's a prebiotic. So a lot of people don't know that. But I have folks just go buy the potato starch powder in a grocery store or health food store, and then just put it in a little drink and down the hatch. That and green banana flour, kiwi flour of all things. So they're all things that have been shown to be really helpful for the gut microbiome.
Yep. And if they're new to you, start slow and kind of build up over
Well,
time.
not so
Don't
much
like
gas in
the
the
full
beginning.
dose. You'll be mad at us.
Yeah. Yeah, well,
Good.
you can always take gas X, um, which helps break up the gas bubbles. So it's not bad stuff. It's just soap.
Yeah. Good. So see, there you go. So prebiotics preferred over probiotics, and also just probiotics probably as food, right? Fermented foods.
Right. Um, we brought this up last time because I was talking about wild brine,
Yep.
and man, I'm going to go have some right after this interview, because I always have wild brine fermented cabbage in my refrigerator. And interestingly enough, I don't digest raw cabbage very well, but wild brine cabbage, I'm fine with it. The green cabbage,
Yeah.
I don't know what it is, but that stuff is addictive.
These foods are delicious, and maybe it takes time to develop a taste for them, but I always have like 8 or 9 different fermented foods because everybody in my family kind of has like the 2 or 3 that they like. And oh no, my kids don't eat it with food. I mean, they do, but they eat it as a snack. Like they come home from school, it's like, Mom, where's the sauerkraut?
Yes.
I'm
Yes.
like, it's so weird, and I love you. So be open to these new things. It will matter, and it doesn't take that long for
Yeah.
things to shift at a molecular level,
Yeah.
right?
So eat
So
your greens, eat your fermented foods, eat your berries.
yeah.
And it may seem like that's really soft science. It's not soft science. That is hard science that, there is, if people ask me for the data, I can pull that up.
And there's
Uh,
a lot of data. It's not a little bit of data.
Not just
So
a little bit of data.
it just like backs up what your grandparents told you, what your parents told you. So let's go to another system. Let's talk about hormones and how we can just help bring hormones back into balance. I think a lot of people immediately think about hormone replacement, which we should
Yep.
talk about as well, but just kind of give us your take on hormones and what are some high yielding things we can do.
So why do women get autoimmune diseases more than men? I mean, men get autoimmune diseases, but why is it so much more of female gender? And there's several theories that are out there. One is that having two X chromosomes means double the trouble because a lot of the immune genes are located on those X chromosomes, right? And so you can almost think every woman is potentially prone to getting autoimmune disease. And there was a fairly new discovery out recently that the reason that doesn't happen is there's all kinds of blocking proteins that are developed that keep that from happening, that actually suppress the immune system. And if you fool with those blocking proteins, then the immune system gets overactive. So it could be that. It could probably also be hormones, right? What happens during pregnancy with MS?
Estrogen.
Well, but what happens to symptoms with MS during pregnancy?
Oh, well, you people, it's the best treatment for MS is what we are
Get
told.
pregnant.
Yeah.
Get pregnant. And so there was some interesting research that came out a few years ago that questioned whether it was a type of estrogen called estriol, that maybe high doses of estriol could actually be used to treat MS because during pregnancy, estriol levels go way up. It's the only time in a woman's life that her estriol levels are up, in fact. Right? And so estriol may have immune regulating properties. And there was some very interesting research that went on actually using high doses like 8 milligrams a day, which is a lot. I'm not exactly sure what happened with that, but I think it was not patentable.
Yeah, I think
Right?
this comes from the work of Dr. Rhonda Voskul and using estriol in the treatment of neurodegenerative conditions, including MS,
Yep.
because this form of estrogen does a good job of getting into the central
Brain.
nervous system,
Yep.
right? Yeah, and it can have a positive effect.
Well,
So
there's
yeah,
a beneficial effect, but then there's another thing going on that probably most OBGYNs don't know about. And that is, how do we process regular estrogen in the body? And it turns out that the same enzymes involved in detoxification are involved in breaking down estrogens, right? And they can convert estrogens into several types, but one in particular is called the 4-hydroxyestrogen. You know about, we talk about it in functional medicine a lot. And the problem with that particular kind of estrogen, the 4-hydroxyestrogen, is that it becomes rancid very quickly. It's prone to oxidation. And a woman named Eleanor Rogan at the University of Omaha has shown that that oxidized 4-hydroxyestrogen can bind the DNA and actually take chunks of DNA out. Okay. Well, why would that be significant? Because the DNA that's left now has an unusual appearance to it. And if the immune system sees that DNA, it can make antibodies. Now, there's a test that we do for autoimmune disease called the anti-nuclear antibody test. And I was trained to run that test on people if I suspected all kinds of autoimmune diseases, but I was never, it was never explained to me why that happened.
right.
And why is it when we get older, then the ANA levels tend to go up? So something must be damaging the DNA that's then exposing it to the immune system. Otherwise, that wouldn't be happening. And again, we know that certain people genetically are more prone to overproducing this abnormal estrogen that can then damage DNA. And the first round of research mostly focused on breast cancer. And Dr. Rogan really thinks that that's one of the main causes of breast cancer, right? And here's the issue, is there certain environmental chemicals that are processed by the same enzymes in the body. They look like estrogens, but they totally jam up all the signaling pathways in the body. So we're only talking about the estrogen that you make in your reproductive organs. That's one thing. But what about what's called xeno, Z-X-E-N-O? Xeno means foreign estrogens, xenoestrogens that we're all exposed to all the time. Plastics, bisphenol A in particular, found in plastics, is a xenoestrogen. It's processed this particular way and has been implicated in autoimmune disease. Now, there's more research on it for rheumatoid arthritis and lupus, but why wouldn't we expect that in a susceptible individual, it could also lead to something like MS?
Absolutely. So what can we do to shift some of these more problematic estrogen metabolites into more favorable ones? What can we do to shift
I'm glad you asked that
that
question.
shift? Yeah.
Well, there's this vegetable called broccoli.
Darn it, broccoli again?
Broccoli, again, actually turns on some of the other enzymes that help shunt the estrogen away from the toxic pathway. Is that amazing or what?
It's incredible. I mean, if
Yeah.
you think about how food and these plants are sort of designed to interact with our bodies, like in a good way,
In a
right? They
good way.
usually improve health unless you're eating something poisonous, but there you go. Like you don't have to go far.
So the theory is that once upon a time, brassica vegetables were poison. But then our ancestors, maybe our simian ancestors, we don't know, but a long, long time ago, our ancestors that got toxic from eating brassica vegetables all died off and didn't pass on their genes. And the rest of us that ate the broccoli that benefited, we lived on and stayed stronger. But now we're in a situation where people don't eat as many fresh fruits and vegetables and berries and things like that. They eat a lot more ultra processed foods.
Yeah.
The question is, why is there more autoimmune disease in our society? And one theory is, well, it's the vitamin D, right? Because people that grow up near the equator are less likely to get MS.
Yep.
So if you have vitamin D exposure when you're younger in life, then all that vitamin D helps program the immune system down the right pathway. But what if you didn't get it? What if you grew up in Scandinavia where they have a lot of MS? And what if you're eating a lot of gluten, which we haven't even talked about on this particular segment, but for people
Another
that are
time.
susceptible, not everybody, but for people that are susceptible, that gluten can be a real problem.
Yeah. So again, it always goes back to lifestyle. And can we also talk about hormone replacement therapy? Like, how do you counsel your patients, a patient with an autoimmune disease, MS or something else? How do we counsel somebody when they
Well,
ask?
of course, that's been up and down because of the confusion about the Women's Health Initiative, the study that purported to show that women that got hormone replacement had more cancer. And so all doctors kind of shied away, not all doctors, but most mainstream doctors kind of shied away from doing hormone replacement. I'm not against hormone replacement at all for a woman with symptoms or a woman with osteoporosis. I think it's very worthwhile. But I'm really careful when I do that. I want to make sure that she's not just taking hormones and that's the end of the story. Here's your script, uh, here's your estrogen patch. And I never use Pravera, which I think is a real medroxyprogesterone is a really toxic substance that should be off the market. I have no hesitation saying that. And that really was borne out in the WHI study, right? So don't do that. Use natural progesterone, which has some anti-inflammatory properties. And don't think that the whole story is take estrogen and you're done. So first of all, you're using the estrogen, just to clarify, to treat symptoms. Hot flashes, dryness, mood disorders. Sometimes it can be miraculous.
Yeah.
I think the New York Times and the Washington Post both had articles about this recently where they were saying, wow, a lot of women have just been told by the doctors, you need to suffer.
Right.
Right? It just, they didn't say that you need to suffer, but they just said, too bad, honey. You don't need these hormones. They'll give you cancer, and that's the end of the story. I don't think that's true. But I do measure those estrogen metabolites. I like to do that in almost every woman I put on hormone replacement. There's a simple urine test that you can do that uses dried urine that's not expensive, a one-time test, and it can determine whether it's safe to proceed with estrogen replacement. So you use the lowest, so you treat symptoms, mostly treat symptoms, use the lowest possible dose, and then you make sure the whole system is healthy, right? The brassica, eat brassica vegetables and curry and berries and all the things that we've talked about. Those are all really important.
Yeah. So that whole lifestyle approach really goes a long way. Like it'll just kind of hit on every system that we've discussed. So just in the time that we have left, could you just spend a few minutes talking to us about sort of what's on the horizon for improving our immune health?
Wait, what's on the horizon? The kind of hot thing right now in the nutritional world is something called pro-resolving mediators, right? So Roy Swank, came up with the famous Swank diet. The whole idea was saturated fat must be bad for you, all bad. And so take out the saturated fat and you can have tons of fish oil, omega-3 fatty acids. Omega-3 fatty acids are great, right? But they're not enough.
Mhm.
And, I've certainly treated people with MS and autoimmune diseases of all types with high doses of omega-3 fatty acids for years. It generally lowers inflammation, but it's not as effective as we'd like. And so what's been found out, and this was, I think it was Dr. Sirhan at Harvard that did all this research that found out part of how these fish oils, the deep sea oils, work is that they're actually producing a whole family of chemicals in the body. And the big name for those is pro-resolving mediators. And they actually seem to be pretty good at quenching the fire of inflammation without poisoning the immune system. So I've been using them more and more in my practice. I don't use them long term. I use them more acutely, but you can use them for everything from a sprained ankle to an autoimmune flare. So I think that's pretty exciting. I think we're going to learn more about them because there's a lot of these chemicals.
Yeah.
Right. So I think that's exciting. I think we're going to learn some things about cannabinoids. Right.
About
So I'm not,
time.
it's about time. I think there's cannabinoids that have not really been appreciated as much as they should be. There's one called beta caryophyllene that's actually found in a lot of different herbs, et cetera. So it's not just about hemp. It's not just about marijuana. That now, there's all kinds of new discoveries about these families, the phytocannabinoids, right? That are in a wide range of plants that have anti-inflammatory properties, immunomodulating properties. So I think that's pretty exciting stuff. I think we're still learning about vitamin D. That I don't have any hesitation to prescribe it, but some of my colleagues still say, well, there's not enough data. Like, how much data do you need to see? They're still nervous to give people more than 400 units a day. That's not enough, right? You need 5,000 or more, and you can measure blood levels to make sure that's okay. There's an herb called andrographis that's been used in Ayurvedic medicine for a long time. Studies coming out showing that that's helpful for multiple sclerosis. So I found that fascinating because we've mostly used that herb for sore throats. Right? But now we know it's an anti-inflammatory, may help with autoimmune disease. There's interesting research on a substance called luteolin, Luteolin. Really interesting work showing that this flavonoid, which is found in a lot of fruits and vegetables, is highly anti-inflammatory and helps seal up a leaky blood-brain barrier.
There you go.
Those just a couple of examples of like where the nutritional research, the herbal research is going. There's a lot going on behind the scenes. And, the drugs that are coming out now, there's how many different drugs for MS? 20, 25 different drugs have kind of stolen the spotlight. And you might think that that's all that's happening. But actually, if you start hanging out with our friend Dr. Google, once you start down a path that may surprise you, what else is out there?
Well, on that note, I'm going to say thank you so much for just sharing your wisdom with us. Like, your knowledge is just so wide. It hits on so many areas. And I hope this gave everybody a good flavor of what functional medicine's all about. Like, clearly, we can't get into all the nitty-gritty detail in an hour, but there are so many actionable things you can do. So do some curd broccoli, like we talked about. Go for a walk outside, get a little more sleep,
Jump in the pool.
jump in the pool, get a little cold. It's okay,
Yes,
right? Yeah,
slightly cold water.
there you go. So this makes me feel hopeful as a patient, as a physician, that there are things I can do for myself, for my patients that are really profound and they work. And they are such a wonderful addition to all the great things you're already doing with your neurologists. So we're not advocating for a functional medicine only approach. We're all about bringing together all the tools so that you can have the best outcome, over your lifetime as you age. So with that, I will say thank you again. I hope we can have you back at another point in time. And we'll see you next time, hopefully
I'll
soon.
come back.
Thank you.
You bet. Bye.